So, couple of takeaways from the quiz. So if we ask you, we say, let's say we have this, because this was something that like a lot of us had some issues with. Oh no, I have x's in the denominator of a fraction. If I want to take the derivative of this, I need to rewrite these so that there are no x's in the denominator of my fraction. How do I do that for 1 over x? I need to use a negative exponent, right? What do I do for 3 over x squared? Same thing, but what do I write then? Good. And then for the last one, what do I do if I have a 2x cubed in the denominator? Just keep the 2 in the denominator, right? Because we don't always, the only trouble with the derivative is the x in the denominator piece. That's all I have to worry about moving. Constants, I do not care about. Now, when I take my derivative, what's the derivative of x to the negative 1? The exponent multiplies to the coefficient, and I subtract 1 from the exponent, right? Everybody's okay there? Okay, what's the next one going to be? Good. And the last one? Good. Everybody's happy there? I think we tripped up some people on that one. The other one that even caused even more problems I don't know, was something like this. So the trick here is we're going to have to simplify this expression before we go. So I want to start by rewriting this as 2 fractions with common denominators. Everybody's cool with me doing that? Then I can just reduce, right? 3x cubed over x squared reduces to 3x. And then negative 7 over x squared reduces, or negative 7x over x squared reduces to negative 7 over x, but I'm not going to write it that way. Yeah, I'm going to write it as negative 7x to the negative 1, right? Because now when I want to take the derivative, what's the derivative of 3x? 3. And the derivative of negative 7x to the negative 1? To the negative 2, right? Because you got to subtract 1 from the exponent. Those were the 2 biggest issues I saw. So I just take a minute and like clarify what to do on those. I don't think those are the exact problems, but it's like it's close enough, right? That was the issue. Same tricks. Today we're going to talk about writing tangent lines and normal lines. So the idea here, say we have some curve y equals f of x, and say we have some point here on the curve xy. Our tangent line is going to be something that looks like this. It's a line whose slope is going to be the same as the derivative of f of x evaluated at that point xy, and it passes through that point xy. The normal is going to be the same idea, but instead of having the same slope as the derivative, it's going to have like a perpendicular to the tangent line. So it's going to be like the negative reciprocal of the derivative. That's the idea. Let's do some examples of doing this. But fairly simple idea. All right, so given the function g of x equals yada, 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 part A, find the gradient of g at x equals 3. When they say gradient, they really mean slope. If I want the slope of a function, what do I need to use? The derivative. So I'm going to begin by calculating the derivative of g. So I'm going to do that term by term. The derivative of negative x squared is negative 2x. The derivative of 8x is 8. And the derivative of negative 14 is 0. So we're just negative 2x plus 8. Everybody feel good? So if we want the gradient then at x equals 3, all we're going to do is plug 3 into our derivative and evaluate, and we get the slope is 2. Part B says to write the equation of the tangent to g of x equals, or to g of x at x equals 3. So our equation for a tangent and the equation for a normal is going to be a line. So you could do y equals mx plus b. You could do ax plus by plus c equals 0. You can do y1 minus, or y minus y1 equals m times x minus x1. That's probably the one that I would use because I'm given a point and a slope. It's like the equation that's tailor-made for that. So we have y minus y1. How do I find y1 though? We're not given that, are we? How do I find y1? I'm just going to plug 3 into the original equation, right? That'll give me the y coordinate on the function. Everybody agree? This tends to be the trickiest piece for students, is going back and forth between the original function, the derivative, and knowing what you need which one to do. It's very easy to kind of get turned around at where you're at. So if I do that, that's negative 9 plus 24 minus 14, so that's 1. So if I distribute through the 2, I have 2x minus 6, and when I add 1 to both sides, I get 2x minus 5. Everybody okay with that? Part C then wants the equation for the normal. Well, I know that is going to be negative 1 over the slope for the tangent. So negative 1/2. So again, I'm going to use my point slope equation for the line. Y1 is still 1, but my slope is now different. So when I distribute the negative 1/2 through, I have negative 1/2 x plus 3 over 2, and when I add the 2 or the 1 over, that becomes 5 over 2. Does everybody feel okay there? So just to kind of illustrate to you what we've done, if we look at our calculator, so I had negative x squared plus 8x minus 14. And then we had the single, the single point 3, 1. And then we had the tangent line 2x minus 5 and the normal line negative 1/2 x plus 5 over 2. I'm going to turn this one off initially. Oops. That's fine. And just graph the tangent one first. I'm going to make the tangent line the thick line. Graph that on a standard window, should probably be fine. There's that. Oops, forgot to turn on plot 1. So there's my point. There's the graph going through it. There's my tangent line to it. That looks nice, right? And then if I tack on my normal, if you watch that come in, it should look very much perpendicular to the tangent. It is perpendicular. Now, the pixel, the screen size not being a perfect square distorts it. It doesn't look necessarily perpendicular. It is, though. Is that okay? Can I show you else something that's kind of cool? So notice here it would ask to find the gradient of g of x when x is equal to 3. The calculator can do that for me. I don't actually have to take the derivative by hand. If you have your calculator with you, I invite you to take it out and follow along. This is pretty cool and helpful. Let's begin by typing in our g of x into y1. Now that we've done that, we're going to press the math button. And we're going to scroll down till we find the d dx, or I'm sorry, n derive. It's Command 8 on my calculator. I'll press enter. So here in the first blank, I'm going to type in an x, because that's the variable that I'm using in my equation. Inside the parentheses, I'm going to type in y1, because that's where I type the equation that I want to differentiate. So I'll press the vars button, yvars, function y1. And where it says x equals, that's where I'm going to put the 3. And I'm going to press enter. Bloop, there's the 2. So even if you don't know how to do the derivative by hand, and they ask you, like, what is the, g prime of 7? And you're like, I don't know how to, I'm not sure I know how to do g prime. Just type in your calculator. Okay? If they want the derivative at a specific value, if they don't want the equation for the derivative, you should no longer do this by hand. Got it? Particularly on the IB exam, because they don't care about shown work. Unless the problem says specifically show, then yes. But if it doesn't say show, they don't care. Use your calculator. Everybody feel good? You're like, Mr. Kulik, how come you didn't tell me that before the last quiz? Well, it's because I do want you to be able to do this. Be able to do this by hand. All right, what if we take this same idea and think about it as like a kind of like a story problem? So it says Lena is designing an archway of a building. The archway should be approximately triangular, but with a rounded top part defined by a parabola. She has sketched the design as shown. The line segments AB, CD are straight lines, while the curve above B and D will be a parabola. The overall height of the archway is unknown. The archway is symmetric, though, about the line x equals 4. It says to write down the gradient of the line segment AB. So gradient means slope, but it's a line segment. How do I find the slope of a line segment? Yeah, y2 minus y1 over x2 minus x1, right? That's Algebra 1 stuff here, guys. Ugh, I have a hitchhiker. You guys ever have that happen on your pens? The magnetic stylus. Somebody was wanting to go for a ride with me. So that appears to be 3. Write down the gradient of the curve at the maximum point of the archway. Right? That's the maximum point of the archway. What's that gradient? Yes, of course. What's the slope of that line? Let me try to redraw it. 0, right? Remember from 10.1, the slope at any extrema, max or min, well, I should say any relative extrema, is going to be 0. Don't even need to do anything with that. Given the parabolic curve is modeled by the function f of x equals yada, 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 find the values of a, b, and c, assuming that the gradient of f of x must equal the gradients of a, b, and c, d where they intersect. Okay. What am I going to do with this? Well, I know that the gradient for AB is 3, right? Let's find the gradient for CD. What do you expect it's going to be? -3, right? So it's 6 minus 0 over, what is that? It's 8 minus 6. Oops, sorry, 6 minus 8. So -3. All right. So this is what I'm going to do. I'm going to calculate the derivative of f of x. What's the derivative of ax squared? 2ax, right? And what's the derivative of bx? And what's the derivative of c? 0. Everybody feel good? A, B, and C are constants, so they don't matter. All we worry about is the x's. Okay. So the slope when x is equals to 2 should equal the slope of AB, right? The slope when x is equal to 6 should equal the slope for DC. So what that's going to do is that's going to form a system of two equations. Oops. That should, okay, dum-dum. X is 2, and then it's 6. There we go. Is everybody okay with what I did there? This system of equations will allow me to solve for A and B. So I have really 4A plus B over 12A plus B. If I just take equation B and subtract equation A from it, that's going to give me 8A equals negative 6. So A is going to equal negative 3/4. Let's just play this out and see what happens. So if that's 3/4, what does B have to be? So B has to be 6. Right? But we also need one other thing, right? So we know that f of x then is negative 3/4 x squared plus 6x. We still don't know what c is. How are we going to find c? I'm just going to use one of the points that I know has to be on f of x. For example, 2, 6. And that'll allow me to solve for c. So there we go. Is that okay? I want to point out to you that you could have also used this here for either one of these two. You could have also said that f prime of 4 has to equal 0. You could have used that in place of one of those other two and still been okay. Is that all right? Again, just because you could, whatever. But that's what you do there. Again, the calculus piece was pretty quick. right? Where did the calculus occur? I mean, just doing that was the only place where we used any calculus. And then after that was all just like algebra, crusty old algebra 1. Really, you know what I'm saying? So that shouldn't have been too bad. Okay. All right, so let's take a look at this next example. When you look at the function h of x here, what do you notice right away? Yep. You know what I notice for you? You have no idea how to take the derivative of that, right? Everybody agree? Guess what? Must be a way for us to do this question without having to actually take the derivative. So we're almost certainly gonna need our calculator to do this. Oh no, hold on. So it's asking us for a normal, right? Everybody agree? So for this normal to be vertical, what does the slope of the tangent line have to be? What's a vertical slope mean? Means that it was a zero denominator, right? Like you have infinite rise over zero run. That's vertical. So what we're going to be looking for is where the derivative is equal to 0. Where is the derivative equal to 0? At the extrema. So what am I going to do? I'm going to graph this thing on my calculator and find the extrema. That'll give me the x's that I need. Is everybody okay with that plan? To follow the logic of what I was doing here so that I didn't have to try to do a derivative that I don't know how to do. For the record, it is not that difficult of a derivative to do by hand. You just need to use something called the quotient rule, which is not that complicated, but I don't think the IB expects you to be using it. So it looks like I have one extrema over here, and then the other extrema is like over there, right? Okay, so I'm going to find the maximum first. That's the extreme on the left side there. So there's what I get. What does that look like to you guys? Look at that x value I got. What do we interpret that as? -1, right? And let's find that other one. That's a minimum up there on the right. That should be good. And I get, that looks like about 4 to me. Everybody's okay there? And that's it. All right. Part B, it says, given the line y equals negative 2x plus k is tangent to h, find all possible values of k. Right? So I'm looking for where the tangent is negative 2. That'll be the same thing as where h prime of x equals negative 2. Let's see. I think they're assuming that we can graph this on our calculators. I'm not positive that's possible. Let's see what it does for us here. The textbook is using like a computer algebra system calculator here to do this. I'm not positive your machines will do this. I guess we can grab both of them at the same time. Oh, it did do it. I'm kind of surprised. Well, that's cool. Everybody see that came in? Do you want to see what I typed in again? So I did that math command 8, and then I typed the equation, and I said x is equal to x. And what we're looking for is when that derivative is equal to negative 2. So I'm going to do negative 2 into y3, and I'm just going to find the intersections. It looked like 2 times that was going to happen. Like once over here, and then another time over there. Right, because here comes y equals negative 2. So second trace, intersect command, enter, enter, enter. One value is about about positive 0.382. And then the other one, I'm going to put my guess right there. 2.62. Now, was that actually what we're looking for in part B? No. What did we want in part B? Values of k. So what we're going to do, we found our x's that'll give us the proper slope, right? We now need to find the y to go with that specific x. What am I going to use to find that y to go with the specific x? H of x. So I'm going to do h of 0.382 and then h of 262. And then once I have that, I'll be able to solve for the k's. So I remember that I plugged that h of x equation to y1. So I'm just going to do y1 of that first guy. And then I'm going to do y1 of that second fella there. So I have negative 0.85 and then 485. So I have negative 0.85 equals negative 2 times 0.382 plus k. And then 485 equals negative 2 times 2.62 plus k. And now I'm just solving for k. What's your best check? Yeah, let's look at the graph here. So I'm going to turn on my h of x. I'm going to get rid of these guys. And then I'm going to graph y equals negative 2x minus, x minus 1.09. And then negative 2x plus 10.1. And just kind of see if those look like they are tangent to the graph. Whoa, those look pretty nice, right? Look like lovely, lovely tangents. That's my easiest check, is to just kind of verify things graphically. And I think we're going to stop here for today. That'll leave us 10-3 for next time, and that'll wrap up chapter 10 for Wednesday. We can worry about review and test after we get back from SB.
Are you excited for SB?
I've never been more excited for an SB than I am right now.
Are you excited for SB? Yeah.
Where are you going?